Lesson 2.8 is solving inequalities. So lesson 2.7 was solving equations, right? We were solving equations pretty much algebraically, but when we went to check them graphically, we could check and see where they cross the x-axis, right? So now we're looking at inequalities. When I say inequalities, I'm talking greater than, less than. So now we're not looking for just where it crosses the x-axis, but we're also looking for what it does above the x-axis, thus greater than, or below the x-axis, thus less than.
Okay, greater than or equal to?
Yes. Yeah.
Isn't that when it touches?
Yeah, we'll talk about it. Okay, so example 1. Ask us to find where a polynomial is 0, positive, or negative. So we're taking our first looks at this, looking at analytically. So we're going to be using a sign chart to do this. But look, notice your equation. F of x equals x plus 3 times x squared plus 1 times x minus 4 quantity squared. Determine the, first we'll note keyword here, real number values of x that cause f of x to be, we're going to talk 0, then we're going to talk positive, and then we're going to talk negative. Now, technically, I would like to argue that you guys know how to do the first part. How do we determine where this equation will equal 0? Okay.
Is there anything to do with that? Is that cubes or not kind of graph looking?
You could talk that, but that doesn't tell me where it's equal to 0. And it's more than just x cubed, technically. Okay. Emma, you said something about set it equal to 0. What do you mean there? Yeah. In order to find where our zeros are, or where this graph equals 0, you're setting each part equal to 0, yes? Okay. X plus 3. What's that tell me? X equals negative 3. So it'll cross the x-axis at negative 3. Okay. What about the x minus 4?
X plus 4, x plus 4.
Okay. It'll cross the x-axis at x equals 4. What about x squared plus 1?
X equals plus or minus squared.
So if we set it equal to 0, x squared plus 1 equals 0, subtract 1. X squared equals negative 1. We're going to take the square root, and x is plus or minus the square root of negative 1, which is plus or minus I. What do the directions say here? Real numbers. So, will x squared plus 1 ever equal 0 in real numbers? No. Imaginary numbers, sure, but is that what I was asking for? Okay, so your answer for part A is doing what you guys already know how to do. X equals, or the function equals 0 at x equals negative 3 and at 4. Let's talk multiplicity for a moment. I want to throw in a little mixed review, and it'll help us understand this problem a little bit. But multiplicity. What's the multiplicity at each of these zeros? 1 and 2? How do we get our multiplicity? The powers, right? If you look at x plus 3, there is no exponent. It's an invisible exponent of 1. So that has a multiplicity of 1. At x minus 4, there's a power of 2. So that has a multiplicity of 2. What do these multiplicities mean is happening? Yeah, do you remember how it designates crossing or touching? If the multiplicity is odd, like 1, it's crossing. So this is going to say, if we graph this on our calculator, my graph is going to cross the x-axis at x equals negative 3. X equals 4 has a multiplicity of 2. What's an even multiplicity say? It touches. Okay, so again, the answer I only really needed for part A is the negative 3 and 4, but I kind of wanted to do that with you. With this, okay, it doesn't tell us how to do this, but we're going to create what I call a sign chart. And so I'm going to draw a long number line, just so I have some room to work. And on that number line, I'm going to put my zeros. What were my zeros? Negative 3 and 4. Now, I'm pretty much going to equally space them out so that it's creating 3 equal sections on this number line. In other words, I'm not putting all the numbers in between. I'm just spacing them out so that they represent 3 separate portions. I'm also going to go ahead, FYI, in case you go back and try and figure out what a sign chart is, this is a sign chart I'm doing. Okay? Now, what we're going to use this sign chart for, okay, is we're trying to figure out, okay, to the left of negative 3. Is my graph positive or negative? Between negative 3 and 4, I want to know, is my graph positive or negative? And then to the right of 4, I want to know, is my graph positive or negative? In each area, I want to test. I want to pick a test value. And I want to test it by putting it into the original equation. Yes, so like over here to the left of negative 3. What's a value that I can use that is left of negative 3? He says negative 4. Do we all have to use negative 4? No. I like it, though. I'm not complaining about it. But someone else could use negative 5. Someone else could use negative 10. We're all going to get the same results. Okay? So I'm going to write down, this is just the first time through, that I'm testing negative 4. I don't care mathematically what the number comes out to be. I care about the sign. So if I put in, it just has to be some number smaller than negative 3. So if I put in negative 4, what do you know about negative 4 plus 3? Negative 4 plus 3 is a negative. Can we agree there? If I put negative 4 into this next parenthesis, negative 4 squared plus 1. It's a positive, yes, because when you square something, you're going to get a positive, and when you add 1, it's still going to be positive. Negative 4 minus 4 is a negative, but then what am I doing with that negative? You're squaring it. So what's it really come out to be? Positive. What is a negative times a positive times a positive? A negative. So here in a moment, when we go back and answer parts B and C, to the left of negative 3, my graph is negative. When I say negative, that means it's going to be below the x-axis. Can we do the same thing from negative 3 to 4? Pick a test value. What do you guys want to use? I always use 0 when I can. You have to pick something that is between negative 3 and 4 and not specifically negative 3 or 4. So negative 2, negative 1, 0, 1, 2, 3. Those would be your easiest pieces. So if we put in 0, 0 plus 3 results in a positive. 0 squared plus 1 results in a positive. 0 minus 4, it's a negative, but then when you square it, it becomes a positive. What's positive times positive times positive? Positive. So my graph between negative 3 and 4 is going to be positive, meaning it's going to be above the x-axis. And do the same thing to the right of 4. Pick a number bigger than 4. 5's what I usually pick. You'd rather pick 10 or 100, go for it. So if I test 5, 5 plus 3 results in a positive. 5 squared plus 1 is a positive. 5 minus 4, positive, and then when you square it, it's still a positive. What's a positive times a positive times a positive? A positive. Okay, it's a sign chart because we're just focused on the signs. Did I actually do the actual math behind it? No. Okay, so part B wanted to know on what intervals my graph will be positive. So where's my graph going to be positive? With the exception, is it positive at 4?
Yeah.
Depends on your definition here. Technically, it was equal to 0 at 4. Okay, so technically we usually say that it's not positive at 4, it's equal to 0. But it is positive from -3 to 4 and from 4 and above, yes? Notice it says we normally use interval notation. So if I'm going to use interval notation, remember interval notation, parenthesis, -3 to 4, parenthesis, and then I'm going to use U for union, and then my other interval is 4 to infinity. Why do they use parentheses and not brackets? Okay, this is not, if the question was when are they positive or 0, we can do that. But it's just when are they positive. And at specifically -3 and 4, they are 0. Okay, C. When is my graph negative? Okay, it's all this stuff to the left of -3. Interval notation, remember reads left to right, so negative infinity to -3. I was plugging my test values into these parentheses. Okay. That was kind of our first run through it here. Do we see a little bit of how that works? We're going to do more, I promise. Stay awake this time.
I don't know if you can see, but AJ just reaches up and like tickles my side, and it is like shake. I don't do anything either. Yeah, and just because of.
Okay. Now, so example 2 specifically says solve a polynomial inequality analytically using algebra. Guys, when they're talking about analytically using algebra, that is their way of saying use a sign chart. Okay, whether we get to it today or not, tomorrow will probably be the graphically. But here, 2 through 12, I said use a sign chart. This is what I'm wanting you to do on 2 through 12. Okay, so we're trying to solve 2x cubed minus 7x squared minus 10x plus 24 greater than 0. What does greater than 0 mean? Okay, and numbers greater than 0 are positive. So what this is saying right here, because my problem says greater than 0, note what it says here in parentheses. Remember, if f of x is greater than 0, then we look for where the graph is positive. So when we do our sign chart, we'll check everything, but our answers are only where the graph is positive. If it said less than 0, then we'd look for negative. Now, since we're doing this algebraically, we're not supposed to be using the calculator necessarily. Okay? We may use it to help us along in one part, which means, okay guys, think back to what we've been doing. How do we find these zeros? Okay.
This one doesn't have the parentheses in it.
Okay, yeah, we can set it equal to 0, but it's not something easy to work with here. Yeah, but it doesn't factor. At least not easily. No, it's an x to the third.
Just not do the product of base equal.
No.
Well, this one has D.
Yeah.
Product of base D.
So what we need here, we need starting points. Numbers that can check. This is not something that we can nicely factor by hand, unfortunately. Okay, we need it factored, but this is not something that will nicely factor by hand. So,
Can you subtract the first term over and then factor?
nope.
We have to do what I think we're going to have to do.
Okay.
What are you thinking we might have to do?
The one, I forget, the negative b plus minus.
No.
Okay.
Quadratic.
You guys are all giving me quadratic things. This is a cubic, guys. We can't just factor into 2 parentheses.
Cubic formula.
We can't. Okay. Was it lesson 2.4 when we began?
I'm not like this.
Talking about, what if I say PRRs?
Oh, yeah.
What are the
I forgot about those. So it'd be.
We need to find some potential rational roots because this isn't going to factor nicely by hand, but we need a factored form. And so we're looking for some PRRs. Okay, so I hear 24 over 2 because it's factors of the constant over factors of the lead. And FYI, I have a lot of different stuff I want to write here, so don't take up a bunch of space doing PRRs. Factors of 24.
plus or minus
1,
1?
2,
Plus or minus
3,
3. Plus or minus 4.
4.
Plus or minus 6.
Okay, yeah, skip 5, so now we're on the other end. 6,
Plus or minus
8,
8. Plus or minus
12,
plus or minus
24. Factors of 2, plus or minus 1 or 2. Now, we can go through and pair those all up if you want. There's a lot of them, aren't there?
Yeah.
What have we been using to kind of, short of just starting and guessing? What have we been using as kind of a speed our process up here? Yeah. We've been looking at the graph a little bit and checking to see what does the graph suggest. If you don't have that option, then you just have to start trying and seeing what happens.
That's one thing we already use.
I am going to use it just because there's so many on this one. So 2x to the third minus 7x squared minus 10x plus 24. Okay, I'm going to do Zoom 6. And here's the idea. There's a whole bunch of PRRs listed there, yes? So do some of those match up? Looks like there's a negative 2, a positive 4,
Yeah, is that a positive 2 or not?
it's definitely not a positive 2, it's something in between 1 and 2.
I think it is kind of like
It could be 1.5 because 1.5 would be 3 halves. Okay, but here's the deal. If we know the first 2, process of elimination will give us the third one here in the end. Okay, so I would say my graph is going to suggest negative 2, 4, maybe 3 halves, but that can just be the third, you'll find out by the end.
Should we trace them or not?
Nope. Because at that point you're turning it into a graphing calculator problem. And this is not what this is supposed to be. Okay. So negative 2, 4, I just put question mark. If you want to write 3 halves because it does kind of look like it, you can. Just realizing it may or may not be right when we get to in the end. Okay, so what do we do to figure this out? After we get our graph suggestions, we use the division. Your classmates are supposed to help you out on that one. Okay, synthetic division. I would start with either negative 2 or 4. So if I start with negative 2, your list of numbers beside it, right? 2, -7, -10, 24. And the idea is we're factoring this as we go. So drop your 2, -2 times 2, -4, add -11, multiply -2 times -11, 22, add -10 plus 22, 12, multiply -2 times 12, -24, add 0. We have a remainder of 0, yes? What's that mean? The -2 worked. What does -2 represent as a factor then? When we go to put this in our parentheses, and we have this all factored out, since this is a -2, this represents the factor x plus 2. And I'm just writing it down there, so I have the visual that, okay, this is one of my factors. Let me zoom in so you guys can see this a little bit better. Okay, so now we're going to use the 4, because the 4 was the other one the graph suggested. Notice he said use those 3 numbers. We're using now 2, -11, and 12. So drop the 2. 4 times 2 is 8. -11 plus 8, -3. 4 times -3, -12. 12 and -12 is 0. What happened? It worked. What does 4 represent as a factor? X minus 4. And we have this remaining piece right here of 2x minus 3 as a factor. Yes?
Then we can add 3 over divided by 2, we get 3 halves.
Okay, so and that does represent, we had guessed earlier that it was 3 halves, didn't we? Honestly, I don't need that because I'm going to use the factor right now. So, first of all, I'm going to write out my original equation was the fact that I had 2x cubed minus 7x squared minus 10x plus 24, correct? We just factored that. Did you guys understand what we did with the synthetic division? Using our PRRs, this now factors into what were our 3 factors? We came up with x plus 2. We came up with x minus 4 and 2x minus 3. That is the factored version of that equation. Not that we had good old-fashioned like product sum factoring techniques or anything that would get us there, but the synthetic division got us there. What we're setting up here is the sign chart, though.
Notice when you say sign chart, I think about SIN.
No. SIGN chart. I am setting up my SIGN chart for Chandler's benefit there. Though the labeling was happening anyways, but the spelling is for Chandler's benefit. Now, what numbers go on my sign chart?
2, or -2 and 4.
-2, 4, and what ended up being our other one?
3 halves.
3 halves. Put them in order left to right. So my smallest one is -2. And just equal spacing between them. After -2, my next biggest one is 3 halves, 1.5, right? And after 3 halves, the next biggest one is 4. I don't have them spaced, like technically spaced out appropriate. I have them equally spaced. Okay. We're going to test into our factored form. So what's a number to the left of -2 you want to use?
Oh, no, sorry, -3.
Okay, -3, -4. So -3 plus 2 or -4 plus 2 or whatever is negative. -3 minus 4 is negative. 2 times negative 3 minus a negative is a negative. What's a negative times a negative times a negative? So this section of the graph is going to be negative.
If it's to the left of a negative number, would it almost always be negative?
Not necessarily. Nope, not necessarily. Okay, between negative 2 and 3 halves. Are you kidding me? Okay, I hate to really just stop right there. It's going to be a pain to pick up tomorrow, but I'm not close enough to where I feel like I can comfortably finish you up. So, tonight, you do not need to work on page 242 unless you really feel the desire. You can work a little bit on it if you want, but I haven't really gotten very far with you. You can continue working on your review worksheet if you want. And I will pick up in that awkward location tomorrow. I totally lost track of time the last couple of minutes of class today.